All right, hello and welcome everybody. This is a little video recorded to walk you through the lecture activity and put you on the right path. We're going to solve some of the problems here together in this video, and others I'm not going to solve, but I want to make sure that you're on the right track as we move forward. So that's kind of the goal here, is to be able to look at these problems and then be able to solve them. Some of them you're going to have to struggle through on your own, but we just want to make sure you're on the right track. So, okay, so let's go ahead and start here. We're starting with naming alkanes. So the first step in naming an alkane is identifying the longest hydrocarbon chain, which is what we call the parent chain. So whichever one is the longest hydrocarbon chain, that's what we want to identify in each of these molecules down here. So the first one's easy. There's only one chain. It starts at this carbon, 1, 2, 3, 4, 5. It's 5 carbons long, so that's a pentane. Now the next one's a little more tricky. You could choose like 1, 2, 3, for example, but of course that's not the longest one. Instead, you would want to go 1, 2, 3, 4. So that's 1, 2, 3, 4. That's a butane. Next up, a few different choices here. Like we could start up here, but it's probably better to start down here because this is going to give us 1, 2 carbons before we get to this other side of the chain rather than just 1 carbon. So we go 1, 2, 3, 4, 5, 6, 7, and that means that it must be a heptane. I'll let you do this one on your own, this one on your own. Let's look at this one, and then I'll let you do this one here as well. So this one actually might be the toughest one here because we have a few different decision points, right? So I'm going to start from here. You could easily start from here as well. As you'd find out, it'd be the same, right? It'd be 1, 2, 1, 2. So that's not going to change anything where we start there. So I'll go 1, 2, 3. Now we have another branch, okay? This way, we go this way. That ends at 4, okay? But obviously, if we go this way, it goes farther. So this must be the correct path then. Now here we're at 1, 2, 3, 4. This one would end at 5. This one would end at 5. Therefore, we have to go 5 and 6, and that's the longest chain. That's a hexane. Okay, so what you want to do is you can kind of identify and name the substituents next. So for example here, I'll let you guys work on these down here. So we'll just kind of work on the ones that we already did up here. So here we have a 1 carbon chain sticking off and another 1 carbon chain sticking off. So these are both methyl groups, methyl and methyl. And we know that this one is a butane, right? Now this one, obviously, it's just 1, 2, 3, 4, 5. That's just a straight pentane. Okay, here's butane. And then we have 2 methyl groups on it. And then if we're identifying, we could go left to right. It'd be 1, 2, the first chain, or 1, 2, the first substituent. So then we go to the next tiebreaker. 1, 2 is the first, 3 is the second, and then up here, 1, 2 is the first, 3 is the second. So it's tied always. What that means is basically it doesn't matter. It's going to be the same name either way. So 1, 2, 3, and 4. So then we see that we've got methyl groups, 2 methyl groups on the 2 and the 3 carbon. So that means to name it, it's going to be 2, 3 dash dimethyl butane. And I kind of ran out of space there. I apologize. This methyl should run into this butane here. Apologies for that. Now with this one, we had a 1, 2, 3, 4, 5, 6, 7 carbon chain. Again, we want the substituent, which we identify right here as a methyl group, to be on the lowest number possible. So that means it's going to be 1, 2, 3, 4, 5, 6, 7, like that. So that's a heptane. And then we have a methyl group on carbon 3, so it's 3-methyl heptane, like that. Okay, so let's do the hard one here together. I'll let you guys kind of like work on these here. We'll do this one, and then I think you guys can, you're able to do these down here as well. Okay, so starting off with, we know that we numbered it correctly. It's 1, 2, 3, 4, 5, 6. Okay, so that's a hexane. Now that's going to be a hexane. And we know that it's hexane, so we have to start either from this carbon or this carbon. So we ask ourselves, where's the first substituent? This one, starting here, would be 1, 2. So the first substituent would be on carbon 2. Starting this way, it'd be on carbon 1, 2, 3. So first substituent wins. That means that this side is going to be where we start numbering. So 1, 2, 3, 4, 5, 6. And then what do we have? We have 1, 2, 3, 4 methyl groups. Wow, that's a lot of methyl groups. And let's go ahead and count what numbers there are. So what that is going to be, it's tetramethylhexane. So we can put that in here, and then we'll worry about the numbering scheme next. So tetramethylhexane. And then where are those methyl groups? They're on carbon 2, carbon 3, and then we have 2 on carbon 4. So we're going to go 2, 3, 4, 4, dash tetramethylhexane. It can be difficult, especially you're doing this in pen, to like put everything together. Just do your best that everything is in the correct order. And again, you just kind of want to show there should be a dash between the numbers and the substituent, and then a dash between different substituents, but no dash between the final substituent and the name of the parent chain. So again, 2, 3, 4, 4, dash tetramethylhexane. So that's the nomenclature activity. There's a couple other ones that we want to just kind of review here. We have some common names. A few of them we went over already, but actually I think there were 2 that I didn't go over in the video, so this is a good time to introduce those. So there was isopropyl, that's kind of the special propyl one. Then you have isobutyl, secbutyl, tertbutyl. Then 2 new ones. We have neopentyl, which looks like a tertbutyl one, but it's just like one separate away. It can be important for a lot of different reasons. And then we have phenyl, which is just a benzene ring, where the benzene is like a substituent, is just named as a substituent. So yeah, so this is kind of the special circumstances that we would use. So let's go ahead, let's actually name this one on number 5 together, just to kind of get the idea of how this is going to work. So here we're going to find the longest carbon chain, 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. That's got to be our parent chain, because check out these benzene rings. They're rings, but they only have 6 carbons. So the longest chain wins. So now, okay, so we've got, we could number it from this way. It's 1 methyl. So it'd be 1, 2. We'd have a methyl group on the second carbon. Or we number it this way, 1, 2. We have a phenyl group on the second carbon. So then we go to the tie break. So we go to the next substituent. Either way, this second methyl group is on the 3. This second phenyl group is on the 3 as well. And actually, if we find it's completely symmetrical all the way down. So now the tie break is going to go to whichever one has the comes first in the alphabet. Methyl, which are over here, versus phenyl. So, of course, M comes before P, so that means that we're going to number it starting on the methyl side. So 1, 2, 3, 4, 5, 6, 7. We have methyl groups on 2 and 3. So it's first off, it's a 7-carbon chain, so that's a heptane. And then we've got methyl groups first, then phenyl groups. So I'm going to number it this way. It's going to be 2, 3, dimethyl. And now we have a different substituent, right? It's phenyl, which is on 5 and 6. So we're going to go dash 5, 6 dash diphenyl. Remember, in this case, the alphabetization is based on the M for methyl and the P for phenyl here. Okay, and then we have some kind of tricky ones down here, which are like kind of harder to kind of identify. But remember, basically, the rule is going to be basically if you have a complex group that doesn't have one of these common names up here, instead what you want to do is go ahead, name it as a substituent. So like find the longest carbon chain. It's almost like a mini problem in itself, where now it's 1, 2, 3, 4 is the longest carbon chain that sticks off of here. So it's a butyl group. And then, numbering it from the carbon that's attached to the parent chain, that's carbon 1. So that's 1, 2, 3, 4. The substituent has a methyl group on the second carbon, so that becomes 2-methyl-butyl. So let's go ahead and name one of these down here. I recommend, this is actually a good time, pause the video and see if you can work on these down here. And then when you come back, we'll work on it together. So I recommend pause the video and then I'll kind of stumble through it with you here. So, oops. There we go. Okay, so here. Now let's go ahead. Let's go ahead and start over here. We want to do the longest possible carbon chain. So let's go ahead and count it up. So I'm going to start down here first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10. That's pretty good. And then up here it could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it could be 10 there as well. Now if we have a tie like we do in this scenario, one thing that we need to make sure is what we're going to do is we're going to pick the one that has the most branches on it. So then we just go back. So starting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, and there is one other possibility, right? It could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, wow. Okay. So I'm glad I did that. Sometimes you get tricked, right? So it's important to check it out. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now we don't even worry about the tie because we just have the longest carbon chain. So 11, if you look it up, that's going to be undecane. Okay, so next up, identify your substituents, right? So easy enough. We have 3 methyl groups here. And then we have this guy right here, right? So this is the longer one here. So now let's go ahead, let's name the substituent first, then we'll worry about numbering the carbons. I like naming the substituents first. I think that works a little bit better. You can do it any order that you want to, obviously. But so first up, we're going to pick the longest carbon chain that includes this as carbon 1. In other words, in the subproblem, we know this is carbon 1. So we really only have 2 choices. We could have a 1, 2 carbon chain or a 1, 2, 3, 4 carbon chain. Of course, 4 is bigger than 2, so that means this is going to be a butyl group. And it's a butyl group that has a methyl sticking off of it, off of carbon 1. So this becomes 1-methyl butyl, like that. And that's going to be how we name that substituent there. So now we have, and then we have 3 methyls, right? Okay, so now here's where it gets a little tricky. When we're alphabetizing these groups, we're going to alphabetize it with this complex one. Think of this as a butyl group. So we're going to use the B when we actually alphabetize it. I know that's extremely confusing, but we have to come up with a set of rules for this. So this is the rules that we've chosen for it. Okay, so in other words, we've got trimethyl, and so which way are we going to number it? Now we're ready to number it, right? So the first substituent is either on carbon 1, 2, 3, or up here, carbon 1, 2, 3, 4. So clearly this one's going to win. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And okay, so let's go ahead. We know that we've got 3 methyl groups on carbons 3, 4, and 8. So that becomes 3, 4, 8 dash trimethyl. Okay, and then we also have the 1-methyl butyl group that's on carbon 6. So look how I'm going to do this here. So I'm kind of running out of space down here, so I'm going to put it in front. I'm going to put it just a little bit up like this. It's on carbon 6, so that's 6 dash. Now, to make sure that we know what we're talking about, we're going to put this name in parentheses, just like what I had here. So 1 dash methyl butyl. End parenthesis. Now we have to separate that methyl butyl from the trimethyl, so we add another dash right there. So that's one way to do it. Now work on this one here. We're going to have the answer for you later with the key, but I want you to kind of like think through it yourself. I don't want to walk through just every problem necessarily here. Okay, naming cycloalkanes. Okay, so remember that we're always going to look for like the longest carbon chain. So that includes like in a ring, for example. So here we have like a cyclohexane ring and we have an ethane, and they're just combined together. So you could either name it ethyl cyclohexane or cyclohexyl ethane. But of course, we're always going to pick the one that has a bigger, more number of carbons, and that in this case is the ring cyclohexane. Over here, in this case, we have cyclopropane versus a butyl group. So here we have this cyclopropane, which is 3 carbons long, compared to a butyl group, which is 4 carbons long. So the main chain is going to be the butane. So we would actually name this, rather than butyl cyclopropane, that's 1-cyclopropyl butane. Okay. Right, okay. So now if you have substituents, this is just kind of like walking you through the rules. This is what we've already done on the lecture slide, so I don't want to spend too much time on this. Once you have that, then your numbering scheme is going to depend on basically the alphabetical order. So you're going to use the same rules where you want to reduce the numbers as much as possible. And like here, for example, it's a tie. Like you could name this as carbon 1 or this is carbon 1. So the tie break goes to the first, naming the lowest alphabetical order substituent, which is M for methyl. So methyl comes first. Okay, so knowing all of that, let's go ahead, let's work on some of these down here. Let's go ahead and I want to pick, let's just do this one here because I think this one's the most interesting. So let's go ahead, take a look at this one here. So we've got a couple options for our chain, right? It could be this 1, 2, 3 carbon chain. Obviously it could be a methane or a methane. That's not going to be the case. Or we have the 5-membered ring, 1, 2, 3, 4, 5. Clearly it's going to be the cyclopentane. That's going to be the most important and longest chain. So cyclopentane, that's going to be our main name here. Then what we have is we have a methyl group. We have a methyl group. And we have an isopropyl group. Okay. Now, overall, again, the tiebreak is going to go to basically we want to name we want to choose one of the carbons to reduce our numbers as much as possible. So we need to either number this 1, 2, 3, 4, 5 or 1, 2, 3, 4, 5. I hope you can see why that is. If we started from over here, we would have one substituent on carbon 1, but then nothing on carbon 2, whereas starting from either one of these gives us a substituent on carbon 1 and on carbon 2. So then we choose between isopropyl and methyl. Well, the I in isopropyl is actually what gets alphabetized, so I comes before M, therefore isopropyl is going to get the benefit. So that becomes carbon 1. Then we're going to reduce the numbering, so carbon 2, carbon 3, carbon 4, carbon 5. Okay, so then when we're numbering it, we see that we have methyl groups on 2 and 4. So that's 2, 4 dash dimethyl. And then coming before that is on carbon 1, 1 dash isopropyl. Dash, right, to separate the numbers there. Okay, give the rest of these a try. Again, we're going to have this on the we're going to have this up on the website, the Canvas website eventually. Yeah, so I hope that walkthrough helps. It gives you like an idea. I'll have this up on the key. Again, if you have any individual questions, go ahead and ask me. This is going to put you through the rigors and kind of show you a few different things, but this is where we want to stop for today on part 1. I hope this video was helpful, and I'm sure if not, at least the key will be helpful to you. So, okay, farewell.